So we have been talking about where we can use quadratic functions to solve problems. And it really involves finding the vertex. In all of these problems, you're going to be finding the vertex. You're definitely going to be finding the x vertex. So you've got to know that formula, negative b over 2a. That's going to be involved in every question. Okay? So we had some questions where you were asked to find the vertex of a situation and explain what both words meant in terms of the problem. Then we went on, and in those problems, you were given the quadratic function. Okay? In these ones that we started in 2.6, you have to make the quadratic function before you go to the vertex. So we talked about a couple of examples. One where you're asked to find missing numbers that differ by something and multiply to get a maximum or minimum. The second type was area, maximizing area, finding dimensions of a rectangular piece of land. The third one involves finding a maximum price to charge in a business. Okay? So let's look at a couple of examples. Here we have an amusement park. Right now, they charge $8 admission, and with that admission, they average 2,000 visitors a day. But they did a survey, and it showed that every time they increased the price by $1, 100 fewer people would visit the park. So what admission cost would give the maximum revenue? Remember, the word revenue also means sales. Maximum sales. Those are interchangeable. So the unknown here, okay, our x is going to be how many times we increase the price. If we increase it once, the price goes up $1. If we increase it twice, it goes up $2. If we increase it 5 times, it goes up $5. So x is going to be the number of price increases, not the actual price increase, how many of them. Well, how do we find how much we get in sales if we sell something? How do you find that? How do you find your sales? What do you do? Addition? What do you multiply? What's that?
Wait, sorry. Price and quantity is total revenue. But are you asking like?
No, you're right. Say it again. Price times quantity. How much you're charging, depending, and how many you sell. So you got to multiply the two. So what I need is I need an algebraic expression for the price, and I need an algebraic expression for the quantity. In this case, is number of visitors. And here's how we do it. What's the price we start at right now? $8. So I'm taking $8 and I'm adding a certain number of increases. That's an expression for the price. If X turns out to be 2, that means our price is going to be $10. If X turns out to be 5, that means our price is going to be $13. So I'm adding X. But when I add X to the price, I'm subtracting it from the visitors. How many visitors do I start with? But every time I do an X, I lose 100. How would I finish this expression? Every time I do an X, I lose 100. Minus 100? X. Minus 100x. Good. That's how we set up the unknowns in this question. So why did I need price and number of visitors? Because to find the max sales or max revenue, I multiply the price by the number of visitors. And then I find the x at the maximum, which means I use negative b over 2a. But before I can do negative b over 2a, I got to put this in the right form. So I have to do 4 multiplications, and then I have to rearrange everything so it looks like standard form. So 8 times 2,000 gives me 16,000. 8 times minus 100x gives me minus 800x. X times 2,000 gives me plus 2,000x. And plus x times minus 100x gives me minus 100x squared. But that's not in the right order. I put the x squared term first, then the x term, then the number. So the negative 100x squared must go first. I can combine these to make what? 1,200, positive 1,200x. And then I've got the 16,000 on the end, which really doesn't factor into this question. Remember, I'm trying to find x at the vertex. I need it in standard form first before I can find x at the vertex, which is negative b over 2a. What's b? 1,200, so it becomes negative 1,200. Over 2 times a, what's a? Negative 100. So when I calculate that, I get 6. That means 6 increases of $1 will maximize my sales. So how much should I charge? $14, right? Because remember, the price is 8 plus however many price increases. We just found I should do 6. So they should charge $8 plus 6 equals $14. Anything more than that, they'll start to lose money. Their sales won't be as great. Because remember, it follows this kind of pattern. Sales keep going up and up as I increase my price, but then they reach a maximum of $14 and then it starts coming down. Sorry, the 14 is here. Okay. So that's the third, yeah.
So, whenever you're doing a question like this, like you're finding, like, how much you find, and always add it to the initial.
Yes. Unless you're decreasing the price.
Oh, okay.
Then you would subtract. Okay, let's look at one more. The sporting goods store sells reusable sports water bottles for $4. At this price, their weekly sales are 80 items. Research says that for every $2 increase in price, the manager can expect the store to sell 10 fewer water bottles. Determine the selling price that will give the maximum revenue, and what will that maximum revenue be? In a question like this, X is always the number of increases or decreases. What kind of increase is going on here? What am I increasing? By $2. So X is the number of $2 increases. So we need an expression for the price and for the number of water bottles in order to multiply them together to get our quadratic function. What's your starting price? 4 plus what? Just 2? 4 plus 2? 4 plus 2x. Because this time every increase is $2. Whereas in the previous one, it was just $1, which is why we just added x. How many bottles did we start with sales? And we lost how many per x? So 80 minus 10x. So your max sales or your max revenue is going to be your price 4 plus 2x times the number of water bottles, 80 minus 10x. I'm going to let you do that. Give it a shot first. So after multiplying them through to get rid of the parentheses, I should end up with 320 minus 40x plus 160x minus 20x squared. Put them in the right order, so the minus 20x squared comes first. Combine the x's to make positive 120x. And I've got a 320 at the end. And notice, if you look at this, and if you think about the graph of a quadratic function, how can you tell that this is a maximum word problem? Okay? Not the y-intercept. How can you tell it's a maximum problem? If you just look at this, because it's negative. Okay? Negative means it goes like this, so it reaches a maximum, it comes down. So with a maximum word problem, the x squared term should always be negative. If it's not, you've made a mistake somewhere. So we now want to find x vertex by doing negative b over 2a. So we get negative 120 over 2 times negative 20. Here's another area where you can check. If you get a negative number, something's gone wrong because a negative number makes no sense. You get positive 3. That means 3 $2 increases. So therefore, they should charge how much? Yeah, 4 plus 3 times 2. They should charge $10 because they started at 4. 3 $2 increases will maximize their revenue, which means a price of $10 will maximize their revenue. Okay. Okay. So that takes care of quadratic functions. So the one question remaining you should now be able to do. Where am I here? There I am.